Hi, I'm David and welcome to What Circuit. For this video we've been given the opportunity to come down to the Motiv8 Forums down in Oxford, which are being held at the Williams F1 Centre, as you can see behind me. We've had a chance to talk to some of the exhibitors and see some of the exciting stuff that they're bringing out at the moment. So without further ado, some of the exhibitors. So we're here with Andy from Yokogawa, who's going to talk to us about a new power analyzer you've got.
Absolutely. Just to give you a little bit of information maybe about Yokogawa. This year is our centenary year, so we're 100 years old. We were formed back in 1915 on our ability to measure electrical power. Today we're going to look at the PX8000. This is a unique product and what it brings to the marketplace. And specifically today we'll look at this little LED demo aid. Here you can see it operating as a standard power analyzer. You can see it's indicating the current voltage that the LED is working off. It's drawing 50 milliamps of current and it is consuming 1.2 watts of power. You can also see at the bottom that it's got a power factor of 0.1. That's not a nice power factor, it's quite a low power factor, very hard to measure. It's great for the consumer, it means they pay less for actually running the light bulb, but from a power generation perspective, the power generators themselves probably won't like it for it. But as you can see here now, it's drawing 50 milliamps, and the purpose of this demonstration is to show you potentially what sort of inrush current you're likely to see when you power the LED up for the first time. So here it's working on a repetitive basis. If I now stop the acquisition and just change the front panel setups, so I come in now and I just change and recall, wrong button, recall the setup. Now we're operating the unit as an oscilloscope. So now what we have, for anybody familiar with an oscilloscope, is we have the overall view of the signal potentially. We have a white box here which is the zoom trace below. We've set the instrument up to look at both channel 1, current channel 1, and also across here on input 3 for current. We have two sensors. We are measuring direct current using these yellow cables, and we have an external current sensor also connected. Now when I've armed the unit, as you can see, it's running. It says it's waiting for trigger, and you can see it's also on the monitor up here. It's looking, I won't say what the trigger level is set for, but it's set fairly high. If the inrush current is below the trigger level, it won't trigger for first initially. So it might take several attempts for the inrush current to be above the trigger level, at which point it will trigger. So when I turn my light off, now I turn it back on again, and there we go. Instantly caught the very first inrush current. The green trace here is powered from the internal connection, and the brown trace is using the external sensor. And if you now focus in, actually here on the peak to peak, you see it's drawn 12 amps. It was drawing 50 milliamps in its steady state condition. On the inrush, it's drawn 12 amps according to this, and if I'm honest with you, actually, you can see here, the waveform is clipped. So in actual fact, the current has gone beyond the capability of this unit, and using the external sensor, we can see it's actually consumed 22.8 amps. Okay, for a small period of time, 13 microseconds. But it's that inrush current which can do so much damage to a product over a period of time, and why products can fail. And so it's the unique capability of this device to enable you to look at the single shot transient events of power that make it so capable.
So it really is bridging the capabilities between an old school power analyzer and an oscilloscope with the power measurement facilities that you'd have around now.
Absolutely. This is two boxes in one. It'll make power measurements to the accuracy of 0.1%, basic power accuracy, but then it'll do your single shot transient type analysis based upon 100 megasamples per second sampling speed, 12-bit vertical resolution. It can have a memory depth out to 100 megapoints of memory behind every single channel. So it really has got the triggering capabilities of an oscilloscope, single shot performance, but it has the accuracy of a power meter, and it's that makes it unique.
So with 100 megasamples per second there, and you're talking about quite a short inrush current with that example just showed on 14 microseconds or so, and you're not even really stretching the capabilities of this then.
No, I mean obviously in terms of current, this will work to 5 amps on an RMS input. Has a crest factor performance of 3, so it can go to 15 amps. That's the reason why with this signal it's been clipped, because it's gone to 22 amps. You can obviously use other external sensors, so you could go up to much higher currents if you wanted to. So yeah, there's an awful lot of capability in here we haven't shown today, things like the harmonic content and those sort of things.
So you talked about the internal current measurement facilities. Is that sort of modular system? You just pick what modules you want to add, or how is that done?
If I turn the instrument round, You can see we have basically a modular based system, so we have 8 input modules potentially. 2 modules form one element, so we have a voltage module and a current module, and then you can multiply that out 4 times, so you can have 4 input elements, so you can look at a 3-phase system or 1 single phase, or 4 single phase devices. You can put a torque speed input, so looking at rotational information, maybe from a motor or something like that. So you could look at efficiency testing, electrical power in, mechanical power out. It can do all that kind of work. Yeah, a lot of flexibility in what it can do.
So with that spare channel then, you've got the ability to be able to correlate, like you say, other measurements together with all the power phase measurements you've got there.
Absolutely.
I presume for sort of motor drives and that kind of thing, you're talking about sort of torque measurements, that's going to be a really useful ability.
So we're seeing applications, in domestic hoovers, vacuum cleaners, where there's an electric motor. Could be a hybrid car, for instance, where they want to look at the powertrain, look at the motors, the inverters, and do the efficiency of the complete powertrain. This is the kind of device that we use for looking at the single-shot transient type applications.
And like I say, that inrush current is the one that managed to blow up capacitors, destroy resistors, all on the input side. So this is going to be able to allow you to really dig into that quickly.
Yeah, I mean, I've seen a situation with a washing machine manufacturer who had a problem with their power supply, and after 3 years the device was failing in the field. We were called in to help look at it. They all saw the same failure. It was the power supply that's failing. Turned out to be one of the capacitors was having a hole burnt in the tantalum by the inrush current, and the product failed over a period of time. It's typically 3 years, and that's the very worst time it could fail, when it's out in the field with a customer. So it's important to capture those design issues up front before a product hits the marketplace.
That's a really interesting product. Thanks for your time.
It's my pleasure.